Hi everyone. In previous lecture, we have already learnt about linked list operations and we have written algorithm for all linked list operations. So today's video, we are going to write implementation using Java programming language. Let's start with class name I have given as linked list and let's start the implementing the linked list. So before adding the methods, first we need to understand how to implement node class because linked list every element is node. Class node, and so currently I'm giving value as int. Once we have finished the implementation, we can use generics and then we can give the generic data type. So first let's finish the implementation using integer data type and node next, so which is giving the link to the next node. So here I'm adding one constructor which will take parameter value and create node for us. So in linked list, we are maintaining two pointers, right? One is head, another one is tail. So first let's define the pointers. First operation which we have discussed is traversal. So to understand traversal, what we have done, we assume that already some linked list is in place. So for example, this is the linked list. Traversal is used in many cases. One best example is printing the data of the linked list. So now let's implement print method which will display what are the elements present in the linked list. So to print the data, from where we have to start, always from the head of the linked list, because at any point of time in linked list, at any node, we only have access what is the next node. So we always have to start with head node. So initialize a current pointer to head of the linked list, and we just have to print the data, means in a loop until current is not null, we just print the data and we have to move to the next node. So to move to the next node, current equal to current dot next. So this is how we are going to print the content of the linked list. Now let's write method for adding the elements into the linked list. Again add, we can add at the beginning, add at the end and add at some random position. So first we will write code for adding at the beginning. Creating a method which will add at the beginning of the linked list. So here we have to accept the value which is data. So before adding the elements, first we have to check already elements present in the linked list or not. So we can expose one more method which will mention whether list is empty or not. So if head node is null, means there are no elements present in the list. This is straightforward, right? So just return head equal to null or not. So first we have to check whether list is empty or not. If list is empty, then obviously this is the first node and this is the head of the linked list as well as the tail of the linked list. So head equal to new node val, then we have to do tail equal to, which also has to point at head node. As we have already added node, just written here. If this is not the case, means already there are some elements present in the linked list, like this case. So in this case, first one is showing already there are 4 nodes present in the linked list, 10, 20, 30, 40, and we have to add a new node at the beginning. Let's assume that value as 5. So what are the steps we have performed? First we have to create a new node. From new node we have to create a pointer to the head of the linked list. Then finally we have to update head to the newly created node, because first node is always head node of the linked list. So now let's write code for this. First we have to create new node. New node equal to val. So this new node should be first node, means new node dot next should point to the current head node of the linked list. Once this is done, because this is the first node, this newly created node is the first node, means head of the linked list should point to newly created node. So this is the code for adding the node at beginning. Now let's write code for adding the element at the end of the linked list. Public void add last. Again, add at the last also. First we have to check whether linked list is empty or not. If linked list is empty, same procedure continues. Just I have reused the code. Here, other than head, other than that, we are maintaining one more pointer which is tail, means which is the last element of the linked list. So now we have to add at the end of the linked list, means newly created node should be the end, right? That means that current last node next should point to the newly created node. Once it is pointing to the newly created node, our tail reference also should change to the newly created node. So let's write code for these operations, these three. Create new node, and then tail.next should point to newly created node. So then it means that new node has been inserted at the end of the linked list. Once it is done, we have to change the tail reference to the newly created node. So this is how we are going to add at the end of the linked list. So just by looking at these operations, you can easily convert into the code. Now let's write code for adding the element at given position. So here we are giving the position and we are giving the value also. So assume that this is the position 1, 2, 3, 4, 5. So if we want to add element at position 1, means we have to add at the beginning of the linked list itself. So this is the base case. If position equal to 1, just we have to call add first method, which we have already implemented. So if this is not the case, for example, position is given as 4, means 1, 2, 3, 4, means we have to insert a new node in between 20 and 30, means we have to add node after 20. So we want to insert node at fourth position, means we should be knowing what is the node at third position, because we have to add next pointer to the third node, right? So first initialize a pointer which is current equal to head. We are starting at head, means we are already at position 1. So initialize count as 1. Now let's traverse the list position minus 1 times, because we have to get this pointer. So 20 pointer, right? So while count less than position minus 1, we just traverse the list. Current equal to current dot next. And here we have to increment count also. So as here there are few cases we are giving invalid position, means we are having only 5 elements in the linked list, but we are giving position as 10. So that particular time we may end up null pointer exception. So for this you can add some validation, validate position using size. But how do we get size? So to get size, we can initialize a variable size, and whenever we are adding the new element, after performing add operation, you can increment the size variable, and if you are performing any delete operation after deleting the node, you can decrement the size by 1. So that way we are going to get size in order of 1 time, and using that you can validate position with size, and then we can throw exception if position is not valid. So while count less than position 1, so this means that we have reached node 20. So once we reach node 20, what we have to do? First we have to create new node. So step 1 is create new node for the given value. So once new node is created, so new node next should point to the current node next, right? Because in between 20 and 30, we are going to add the new node. So new node next should be current dot next, and our current node next should point to new node. So we have added all add operations. Now let's write code for delete operations as well. So delete also similar way, we can delete at the beginning, we can delete the node at the end, and we can delete a node at given position. So first one is delete at beginning. What is the value has been deleted from the linked list. So return type I am giving as int. Here also first we have to check whether list is empty or not. If is empty, then we have to throw exception. Initialize pointer current to head of the linked list. If you look at this image, we have to delete first node means we just have to remove this element, right? Means we have to remove the connection from this node to the next node. And at the same time, our head should point to the new node. So first what we have done, head equal to head dot next. For changing the head variable, just I have taken head reference to the current variable so that I can return the data. Return current dot val. So this is the method to delete the node at the beginning of the linked list. So here we have to make sure one more thing, that suppose if we are having only one node in the linked list, so that node itself we have deleted. That means that our list is going to be empty. This is the case, tail also should point to null. So next one, now let's write code for deleting the element end, means deleting the last node of the linked list. So first one is again pre-check whether list is empty or not. If list is empty, just throw exception. If list is not empty, so we know what is the last element. To delete last element, what we have to do, previous node next should point to null. But from last node, we don't have reference what is the previous element. We always have the reference what is the next element, right? So it means that we have to start with head. We have to reach the node which is previous to the last element. So means first we have to traverse the list. So while traversing the list, we should have the pointer which is previous to the last element of the linked list, right? So this is my current node, means this is my previous node. So here we will maintain two pointers. One is current, another one is previous. So first initialize current to head. Current is head means what is the previous to head? Nothing is there. It means that null. So previous equal to null. Then we have to traverse the list until end of the linked list, right? How do we do? While current dot next not equal to null. Then we have to first update previous equal to current, and then current we have to move one step forward. Current equal to current dot next. At the end, what we are going to have, previous will come here, and then current will be pointing to last node of the linked list. So previous dot next should be updated to null, and at the same time, as we are maintaining the tail of the linked list, tail should point to previous node. So which element we have removed? Current, right? So return current dot val. So this is the method which will delete the node at the end of the list. But still we have missed one more case. For example, we are having only one node in the linked list. Then here we are going to get null pointer exception, right? Because there is no previous node. So means we have to add one more case here, if head equal to tail or head dot next equal to null. Anything works. First we are returning the data which we have deleted, right? So int val equal to head dot val, and simply we can update head and tail pointers to null. So this is the code for deleting the element at the last. Now let's write code for deleting the element at given position. So here position is given, public int delete and int position. So suppose I want to delete node at third position. So I'm starting position, head node position is 1. I'm starting with 1 here, 1, 2 and 3. So I want to delete node 25 from the linked list. So 20 next should point to 25 next, and we have to break this link. So this link is automatically gets deleted. So this link we have to update to null. We have to delete 25 means what we have to know, what is the previous node and what is the next node. So then only we can perform this step, right? So to do that, we have to traverse the list till 25. At the same time, we need to maintain one more pointer which is previous to 25. So that means that let's define two pointers here. So base case first let's write. If list is empty, then we have to throw exception. So if this is not the case, first we have to initialize node current equal to head, and then previous to current is currently null. Node previous equal to null. Maintain variable count which is currently 1 because already current is pointing at head. Current node should reach 25 means we have to traverse position times. So previous we have to update to current, and then current should point to current dot next. So once it is done, similar way whatever we have performed here, same thing we have to perform here also. Previous dot next equal to current dot next because we are going to delete current element, and then current dot next should point to null. Finally, we have to return current dot val. So here also there is possibility if there is only one node present in the list, then the previous node is obviously null, right? So there is possibility of null pointer exception. So if there is only one node present in the list means we are going to delete first node only, right? So if position equal to 1, then we are going to delete first itself. So directly we can call this method. So this is how we are going to perform the delete operation. Another operation which we have discussed is search. For example, I have a linked list. I want to know whether element 30 present in the list or not. For that, we have to traverse the list, and every time we are going to compare the data of the node with the given value. So if it is matching, we are going to return it. Otherwise, we are going to proceed further until we reach end of the list. So now let's write code for that. Public boolean search, and we are giving value. So we are going to start with head node only, and what we will do, we will just check whether current not equal to null or not. If it is not null, we have to compare current node value with given value, then return true. So every time we are moving current to current dot next. If condition we are not satisfying means we have reached end of the list. That means that we didn't find the given value in our linked list, means we are going to print the false. This is the method for searching the element in the given linked list. So now let's write main method, and I have added few add operations and few delete operations, and every time after performing some operation I am printing the linked list to understand how it is performing. Now let's. So after adding 20 at first 20, after adding 10 at first, 10 20 null, after adding 30 at last, 10 20 30, right? After adding 40, then 40 added at the end, after adding 5 at first, 5 added at the front, after adding 25 at position 4. So 1 2 3 4, so 25 has been added at position 4. So then I have performed delete operation. So first node deleted means 5 has been deleted, and after deleting node at position 3 means 25 has been deleted. So here we have given value as type int. So I can create only linked list of integer data type. For example, I want to create a linked list with string data type or some user defined data type. So how can we reuse the same code? So in Java, we have generics concept. So using generics, we can define generic data type, and then we can give what are the data type we want to create the linked list. So here I'm just giving type as value. So using this only, so while initializing, so linked list integer. So then I have to create nodes of type integer only. So here I'm going to give value. So everywhere I'm going to change the same thing. Now let's see. So now let's run the code again. So again it has given same output. So now let's create another linked list which will take string ll1 dot add first 1. Again I'm running the code. So first element is 1 and second element is 2 because 2 has been added at the last. So same code we just converted using generics, which we can store any type of values like integer, string, or else it can be user defined data type also. I hope this video is clear to you. So the code implementation link has been provided in the description. Thank you for watching. Stay tuned. Happy learning.